from those particles which were generated 13 billion years ago. Somehow here we are today, intelligent people having a discussion here, or all the beautiful world which is around us. So what we're trying to do in exploring space is to try to understand how did stars form, how did galaxies form, how did planets form. Are there many planets in this universe? Are these planets similar to ours, or are they very different? If they are similar to ours, did life evolve on these other planets? If we find that life is fairly common in the universe, that would be a very enlightening, kind of discovery. And then we have to find, are they similar life to us? Is there the same DNA, that exists here on Earth, is also the same DNA which is across the solar system or across the universe? Or if, on the other hand, life is only here, out of all these billions and billions of stars and planets, there is only life on this planet, that also would be equally dramatic to understand that. So our mission of exploration is to try to understand in what I call write the book of how actually things have evolved to where we are today, and then to tell us where are we heading, if we can extrapolate from it. So as we speak today, just NASA, in the United States, have almost 70 spacecraft which are across the solar system and around the planets here. Just from JPL, if you come and visit us, we take you to our mission operation room, which we say is the center of the universe. And that's where we're controlling spacecraft which are around Jupiter, around Saturn, going to comets, on Mars, roving on Mars, all being done, as our emissary, our robotic emissaries, which are conducting this exploration, on our behalf. And then here on Earth, now many people don't appreciate the dive-in-weather.com. Many people don't realize it's coming from satellites, which are in orbit around Earth. Many of the communication that we do, the high-capacity communication, which goes through satellites, or the monitoring. If you Google, Kuwait, city, and you look at the Marina Hotel, you can get a picture that's all coming from these satellites. All of this has happened during our lifetime. When I was a student, there was nothing, these things. We barely were just starting, to launch satellite in space. So just in a period of 40, 50 years, it changed completely our way of how do we apply it to our planet and how do we explore the universe. Now, one of the targets, or one of the places that always gets a lot of attention when we talk about exploring the solar system is the planet Mars. Mars is fairly close to us, relatively speaking. It takes about 6 months, to get to Mars, still at very high speed, but it takes 6 months. Mars looks very similar to Earth. It's about the same size as the land mass on Earth. It's 1/4 the size of Earth, but on Earth 3/4 is water, so the land mass on Mars, land mass on Earth is the same. There is an atmosphere. It's much thinner than Earth. There are many features which are similar to Earth, the same way we have a Grand Canyon in the United States. There is also a big Grand Canyon on Mars, which says that the geologic forces which are occurring on Mars are similar to what is happening on Earth. Matter of fact, the Grand Canyon on Mars, which is on your left, is basically the same size as the football United States, going from east to the west of the United States. You have volcanoes on Mars, similar to Earth. On the right, that's an Earth volcano. On your left, that's a picture of Mount Olympus, which is the largest, volcano on Mars. It's not active today, but clearly in the past, there was volcanic activity which occurred on that planet. I always give my students a test for this picture. I tell them, guess which one from Mars and which one was taken in Chile. Matter of fact, I lost track, unless I have the name under it. I usually lose track myself which one it is. In actuality, the one to the left is a picture taken on Mars from one of the rovers. The one to the right was taken in one of the deserts, in Chile. They look very similar. So it says that the geologic phenomena are very similar on the two planets. Now, as we speak today, we have 2 rovers which are exploring the planet on our behalf, and we have 2 orbiters from the United States and 1 orbiter from Europe. And the reason I want to show this picture, because for me it represents what has been accomplished. For thousands of years, our ancestors, traveling in the desert, traveling on the ocean, used to look in the sky and see that red planet or that red star and wonder what's on it. And here, our generation, now we have rovers which are traveling on that planet. So you are seeing the tracks, of the rovers on the surface of Mars, that we are basically operating them day in and day out. And we are discovering things very similar to what we see here. So here, what I want to show you is we are exploring one very large crater, on the surface of Mars. And if I zoom down from the satellite, and let me see that little dot in here, That's actually the rover which is on that planet, which is roving around and exploring that planet. So that gives you an idea about what we are capable to do from orbit, looking at the surface and tracking those rovers as they are traveling, and exploring that planet. And the reason we are very excited about exploring craters is because what craters are is like a very big hole in the ground. So for a geologist, it will allow us to see what's below the surface. And as we see the layers which are below the surface and analyzing these different layers, that allow us to determine what happened in the past. Because the lower layers were deposited before the one above it, before the one which is above it. So by reading the layers, basically we are going back in history and determining what was the composition, what happened during that period in the past. And to make a long story short, what we believe today is that actually there were oceans on Mars a few billion years ago, similar to the oceans on Earth. And for some reason, those oceans disappeared. And that water either went into the atmosphere or went below the surface. So the immediate next question, if there were oceans, is life evolved in those oceans? And if life evolved, where is it today? Because we don't see it. Can we see some of the remnants of those life inside those rocks? The same way now we learn about the past history of Earth by looking at rocks and looking at some of the features and the materials which are in those rocks. And this is one example, I should have put that one earlier. We'll show you also a similar example taken from the rover picture of sand dunes. You would have thought you are in Oman or Saudi Arabia or anything like this. So that shows you the similarity, that also the wind phenomena are very similar between that planet and our planet. Now, more recently, literally about 9 months ago, we decided to send a spacecraft to go to the North Pole of Mars. And the reason we wanted to go to the North Pole is to be able to determine the ice that we see at the North Pole, is it made of water? And then to take samples of that ice and see if there are any organic material which have been frozen inside that ice. So to give you an idea, if we would have landed it on Earth, it would have been like landing in northern Canada. So we did that last Memorial Day in the United States, so that was last May, about almost 10 months ago. And this is one particularly interesting image because from the orbiter, as we were coming in and landing, we started taking pictures of the spacecraft coming in to land on the surface. And you see that square, you see in the middle of it a little bright dot. And if you blow it up, that shows our lander coming down with the parachute behind it. So just imagine, this was taken from orbit on another planet, taking a picture of a lander coming on a parachute, landing on that planet. I mean, when you think about it, it's absolutely amazing. How could that have been accomplished? Now, we landed on that surface, and this is what we saw on the North Pole of Mars. And here I want to tell you a little bit of an anecdote that happened. Immediately after we landed, we had a press conference, like about an hour after the landing. So I was sitting at the podium, and a reporter raised his hand and he said, "Well, I see a white feature just at the top right there. What is that?" And we had no idea because we just started seeing those pictures ourselves. So jokingly, I said, "Well, that must be a polar bear which is walking." Well, 15 minutes later, one of our computer analysts basically put this on the screen. He was able to go and get a picture of a polar bear, put it in the picture here, and then we showed it to the media. So that shows you sometime, the power of the image processing that people can do today. But in reality, we did not see polar bears for Mars. But what we have done, on that lander, we actually had an arm similar to your arm. And at the end of it, there was a little backbone. What you were trying to do is to actually dig in the surface and see what's below the surface, take samples, and put those samples into ovens, heat them so we can determine what kind of gas is emitted, out of those ovens. And to show you an example, this is where we actually were doing, this benching. And you see that white area that indicated that there was ice just below the surface. So there was a thin layer of dust. And just about a few centimeters below the surface, there was a layer of frozen ice. And when we did the analysis, that turned out to be water ice. And then we found a number of organic material which are in it. And we're still in the process of analyzing, that data. All of that done in the last 6 months. Now, to tell you what we are doing next, you see here is what we call the family portrait of the rovers that we're developing at JPL. This is the center that I'm the director of. On the far right, to your right, that's a rover that we launched about 10 years ago. It's about the size of a shoe box.